let's dive right in. In pretty much any building you're in, there's a silent guardian watching over you, right? A system that's designed to be the one thing standing between a close call and a total catastrophe. We don't really think about how it works, but today, we're pulling back the curtain on that very system, the fire alarm. And look, this is about way more than just bells and flashing lights. We're going to take a deep dive into the evolution from simple alerts to the truly intelligent, life-saving networks that protect us every single day. Okay, before we get into any of the tech, the wires, the gadgets, we have to start with the most fundamental purpose. Just for a second, forget about protecting the property, or business continuity, or even the building codes. At its absolute core, a fire alarm system exists for one single reason, and that is to protect life. That's it. It's the non-negotiable foundation for this entire industry. And protecting life isn't just about making a loud noise. A modern system is really like a building's central nervous system during a crisis. Its whole job is to step into a moment of pure chaos and inject order, guiding people to safety and coordinating all of the building's automated functions in a really predictable, structured way. So how did we get to this point? Well, the technology has evolved dramatically. And you can really break it down into two totally distinct eras. And these aren't just little upgrades we're talking about, they are two major categories of systems that are fundamentally different in how they think and how they communicate. So what are those two categories? They're what we call conventional and addressable systems. Conventional is kind of the old school, simpler approach that just groups devices together. Addressable, on the other hand, is the modern, intelligent approach, where every single device is its own unique entity. Let's break down exactly what that means. A conventional system works by wiring a whole group of detectors together into a single circuit, and that's called a zone. Think of it like a neighborhood. When one smoke detector activates, the main panel only knows that something in that neighborhood, say the entire third floor, is an alarm. It can't tell you which house is on fire, only that there's a problem somewhere in the neighborhood. An addressable system, though, that's a whole different ballgame. It gives every single device its own unique digital street address. It could be something super specific like smoke detector, room 101, or manual call point by the east exit. So when that device activates, the panel knows instantly and exactly which house is calling for help. There is zero ambiguity. Zero. And this distinction right here, this leads us to the crucial point of this whole explainer. This isn't just some techie upgrade. It's a fundamental shift from guesswork to absolute certainty. And in an emergency, trust me, that difference is everything. So here's the real-world impact of that difference. A conventional panel forces first responders to search an entire area. Zone 3 in alarm could be a whole floor with dozens and dozens of rooms. But an addressable panel, that gives them immediate, actionable intelligence. They know precisely where they need to go, and that saves critical seconds when every single one counts. This precision creates huge advantages all across the board. Response time is obviously faster, right? But look at fault finding. With a conventional system, you might just get a fault in Zone 3 message, leaving a technician to test every single device to find the problem. An addressable system just says, hey, the detector in room 402 has a fault. Maintenance becomes proactive, not reactive. And finally, flexibility. The ability to program intelligent responses, which, as we're about to see, is a complete game changer. So how does all this work under the hood? I mean, to really get the power of an addressable system, we need to look at its core components and see how they all work together to create this amazing intelligent network. At the heart of it all, you've got the fire alarm control panel. This is the brain. It's constantly polling every single device, asking, you good? You good? Listening for any sign of alarm or fault, and it's where all the programming, the cause and effect logic, is stored and executed. It makes all the big decisions. Now, the devices communicate with the brain through something called the loop, and the efficiency here is just so impressive. This one single pair of wires delivers both power to the devices and carries all the digital communication back and forth. These loops are also incredibly resilient. They have built-in isolators that can automatically disconnect a small section if there's a wiring fault, keeping the rest of the system online. Pretty clever. Then you have the sensors, the eyes and ears of the system. And we're talking about intelligent smoke and heat detectors that can analyze conditions over time to tell the difference between a real fire and, a bit of steam from a shower. This drastically reduces false alarms. And of course, you've got the manual call points, each with their own unique address, so you know exactly where someone pulled the alarm. And finally, we have modules. Now, these are the real unsung heroes of the system. They act as a bridge, allowing the fire alarm's brain to talk to and control all the other critical systems in the building, things like elevators, fans, and door releases. This is what allows the system to take coordinated, building-wide action. So when you put all of these components together, you get something that acts less like a simple alarm and a lot more like the building's nervous system, a fully integrated network that can sense, think, and act. Here's how that logic actually plays out in real time. A single detector might just trigger a local alert for staff to investigate. No need to panic the whole building, right? But if a second nearby device confirms the event, well, now the system escalates automatically. It recalls the lifts to the ground floor so no one gets trapped, it shuts down ventilation to stop smoke from spreading through the ducts, and it automatically notifies emergency services. See? It's a phased, intelligent response, not just a simple on-off switch. So let's bring this all back home. Why does all this technology, all this detail, actually matter? What is the ultimate payoff for choosing a system that's this advanced? Well, the payoff is most obvious in really complex environments. Just think about a hospital or an airport. You absolutely cannot afford to have a vague alarm that requires a 20-minute search. You need precise information, and you need it instantly. You need the system to integrate with dozens of other services. In these places, the clarity and control of an addressable system isn't some luxury. It's an absolute necessity. This quote from the source material just perfectly summarizes the entire philosophy. Addressable systems exist for any environment where the stakes are too high, the layout is too complicated, and where the cost of being wrong is simply unacceptable. So the key takeaway from this whole thing is this. The leap from conventional to addressable isn't really a story about better detectors or fancier panels. It's a story about better information. It's about transforming a dangerous, chaotic event into a manageable one by providing clear, precise, and actionable data exactly when it's needed most. And that leaves us with a final question to consider. When it comes to the systems designed to protect us, are they providing a general guess about where the danger might be? Or are they providing a hard, actionable fact? The answer to that question, well, it can make all the difference in the world.